How does thermal radiation work in heat transfer? Imagine standing near a campfire on a chilly night. You feel the warmth even if you're not directly touching the flames. That's thermal radiation at work. It's a way heat moves through electromagnetic waves, mainly in the infrared spectrum, from a hot object to its surroundings. Unlike heat transfer by conduction or convection, radiation doesn't need air or a solid to pass through. It can travel across a vacuum, which makes it special. At the tiny level of atoms and molecules, thermal radiation comes from the random motion of charged particles like electrons and protons. When these particles move, they emit electromagnetic waves that carry energy away. The hotter the object, the more radiation it emits. Also, the wavelengths of this radiation get shorter as temperature increases. So, a very hot object like a furnace glows with visible light, while cooler objects mainly emit infrared waves you can't see. The key law that explains how much energy an object radiates is called the Stefan-Boltzmann law. It states that the total energy radiated per square meter of a perfect black body is proportional to the fourth power of its absolute temperature in Kelvin. But real surfaces aren't perfect emitters. They have an emissivity value, which measures how effectively a surface emits radiation compared to a perfect black body. A shiny metal surface, for example, has low emissivity and emits less radiation. When two surfaces exchange heat through radiation, several factors come into play. Their temperatures matter, with heat flowing from the hotter to the cooler surface. The size of the surfaces and their shape also influence how much heat is transferred. This is called the view factor, which describes how much one surface sees the other. The net heat transfer depends on the difference in radiation between the two, and it follows the second law of thermodynamics. In real-world engineering, radiation is very important in high-temperature systems. Think about furnaces, engines, or even spacecraft. Spacecraft use radiation to get rid of excess heat because there's no air in space to carry it away through convection or conduction. The surfaces of spacecraft are designed with specific emissivities to control how much heat they emit or absorb. So, in simple terms, thermal radiation transfers heat through electromagnetic waves emitted by hot objects. It doesn't need a medium, follows the Stefan-Boltzmann law, and depends on surface properties and how the objects are arranged. It's a vital part of heat transfer analysis, especially when dealing with high temperatures or vacuum conditions.